In alternating current systems, the flow of current or voltage varies with time, and this variation follows a specific shape called a waveform. The most common waveform is the sine wave, shown at the top of the image. In this sine wave, the current or voltage starts from zero, rises to a maximum positive value called the peak value, denoted as Vm for voltage or M for current, then returns to zero, drops to a maximum negative value, and again returns to zero. This complete journey from zero to positive, to negative, and back to zero is called one full cycle. The time taken to complete one cycle is called the time period, represented as t. The first half of the cycle is called the positive half cycle, and the second half is the negative half cycle. The mathematical expression for these waveforms is given as v, t, equals Vm sine omega t for voltage, and I, t, equals M sine omega t for current, where omega represents the angular frequency. The section in the middle of the image shows different types of waveforms: sine, square, triangle, and sawtooth. Each of these has different shapes and characteristics, which affect how energy is delivered in a circuit. For example, a square wave switches sharply between high and low values, while a triangle wave changes gradually. These waveforms are used in different applications depending on the requirement. On the bottom part of the image, we see the concept of instantaneous value. The instantaneous value is the value of voltage or current at any specific moment in time along the waveform. For example, at a particular time, the current might be I1, I2, I3, and so on, depending on the sine wave's position at that instant. These values are important for analyzing AC circuits at different time points. The instantaneous value of current is represented as small I, and the instantaneous voltage is represented as small v. In simple terms, if you pause the wave at any random time, the height of the wave at that point gives you the instantaneous value. Understanding these basic concepts helps in analyzing and designing AC circuits, and forms the foundation for learning more complex electrical engineering topics.